These are two portions, synchronous machine and the induction machine. So the synchronous machine is the G43 and induction machine is the G45. So this is called as G43 plus the G045. So this is a two machine. So the first thing we can draw is rotating speeds are due to the three-phase winding. When we connect the electricity supply to the three-phase motor, so the three-phase winding produces a rotating magnetic field. Rotating magnetic field is developed in the three-phase winding. So this three-phase winding rotating magnetic field, we can draw this diagram. So this way we just motor winding here. This is motor armature. So that way we just A, and this is for the A dash, and this is for the B. So this is B. So this will be the B dash, and this one will be the C and the C dash. So this is the three winding. So this is a A. This is a starting point. A dash means end point. So this is for the Y3 windings. You can see that this diagram. And then into this three-phase winding, the voltage vector will be produced. The voltage vector will be this direction. So that will be the force A. This is force produced in the FA. And this becomes FB. And this is for the FC. So FA, FE, SC are the voltage direction that is produced in a three-phase winding field. So in the three-phase winding field, we can draw this diagram. So that will be the stator winding. So this is for the FA. And this one will be the FE. And this is the SC. So then we will get our force. FS. So FA, FE, SC are the stator field, and FS means rotor winding magnetic field direction. So then we will get FA, FB, SC. So stator field direction. And FX means rotor field direction. So voltage produced in the stator field and rotor field according to this direction. Now because of this one, we can now calculate the force direction. The force happening in the A phase current, B phase current, C phase current, we can write by the equation. So IA is equal to the equation with the IM cos omega t. So this is for the IM is the maximum current, omega means rotational flux. Omega you can calculate 2 pi multiplied f. So it is pi is 3.1416. A is the frequency. Frequency half. So we can calculate. So IA is the I maximum cos omega t. So this equation. So then one we can calculate the equation like this. IM by 2 and e power j omega t plus e power minus j omega t. This is for the A phase current we can calculate. And similarly, B phase current you can also calculate. So IM by 2 e power j omega t minus 2 pi by 3 plus e power minus j omega t minus 2 pi by 3. So this is for the B phase current you can calculate. And C phase current you can also calculate. IC is equal to IM by 2 e power j omega t plus 2 pi by 3 plus e power minus j omega t plus 2 pi by 3. So A, B, C, the phase current can be calculated by this formula. Because of this formula, the force, the rotational force produced by the FA. FA is the rotational force. The FA you can calculate by this equation. So IN multiply N divided by 2. IN is the maximum current. I is the maximum current. And N is the speed. So this is the rotational speed. So this is RPM. We can calculate IM multiply N by 2. So that will be E power j omega t plus E power minus j omega t into the J0. So E power J0. So this is for the FA we can calculate. And FB means B phase windings are force you can calculate the IM by 2. IN by 2. So the formula E power j omega t plus E power minus j omega t minus 4 pi by 3. And also FE. FE you can calculate. So IM N by 2. So this will be the E power j omega t plus E power minus j omega t plus 4 pi by 3. So those are the force formula. Magnetic force produced by the generator winding. We can calculate by this way. So all the things we can use it for. Generalized formula is F is equal to 3IM N by 2 E power j omega t. So this is the rotational force. Force produced by the three-phase winding. So IM is the maximum current. And N is the speed. So this is for the AC machines are three-phase rotational speed production. So when the AC machine windings are there are three-phase theta winding and this is rotor speed. They produce a magnetic flux. So the magnetic flux, so magnetizing force are produced can be calculated by this equation. So FA, FE, SE for the magnetizing force are produced by the A winding, B winding, C winding. FF means the magnetizing force produced in the rotor winding. So in the summary, we can write the magnetizing force. F is equal to 3IM N by 2 into the E power j omega t. So I is the maximum current and this is the number of turns. So can be produced by this AC machine. Okay, the next one is we can find the current rotor position. The rotor is rotating. So when the rotor rotates, depending on the rotor position, the current will be the changing. So we can plot the rotor position and the current value. So this is position of rotor. And this one will be the IA, IB, and the IC. So that when the position of rotor is 0, IA is a maximum IM. IB is a minus IM. IC also is a minus IM. Minus half IM. So this is for the position rotor 0. And 30 degree. So that will be the root 3 by 2 IM. So 0 minus root 3 by 2 IM. And 60 degrees. So that will be the half IM. So that will be the half IM. So this is minus IM. And 90 degrees. So 0 root 3 by 2 IM. So minus root 3 by 2 IM. So those are position of rotor and neck. Current IA, IB, IC magnitude. All the state of windings are 120 degrees apart. So this means that when you work at the AC machine, the windings are 120 degrees apart. 120 degrees apart means that the whole winding here. So if you put a one winding, another winding has to be put this way, another by this way. So 120 degrees apart. The current must be flow into this direction. So this is I show you the current flow direction. So currents are the flowing across in this direction. This is a top. So this is top means that current will flow into this direction. Okay, here current flow into this direction. Here is the current flow into this direction. So currents are flowing in this direction, and also all windings has to be 120 degrees apart. And rotating magnetic field produced can be calculated by this formula. F is equal to 3 IM by 2 multiplied with e power j omega t. So this is for the current produced in the 3-phase AC machine. Connected. So this is we can draw a state winding direction here. So this is a 3-phase machine. So 3-phase machine, we can draw the state winding diagram. So this is for the A phase. This will be A and A dash. So winding one like this. And this one will be the A dash here. So this is for the A phase. So this is for A phase winding. And also there's our B phase. So this is for B phase. B and this one will be the B dash. So this winding will be like this. So this is B phase. So this one is connected here. This is a B-phase winding. B-phase winding is connected like this. And also the C-phase. The C-phase winding is here, IC. And this one goes to the C-phase. So this one is winding is from this is C, so this is for the C dash. So this C dash is for the like this. So then will be the ABC will be the terminal, and this is for the star point. So this is for connection of the 3-phase AC machine. So connection of 3-phase machine. machine speed. So machine speed can be calculated by formula. So for the AC machine speed depending on the frequency and the number of poles. So we can calculate synchronous speed. The synchronous speed will be NS. We can calculate by this formula. 120 F divided by B. And that's equal to 120 F by B. So this is the synchronous speed of the AC machine. So in this case, our NS is equal to the synchronous speed. And S is the frequency of the pole. And P is the number of poles. So NS is synchronous speed, S is the frequency, P is the number of poles. So synchronous speed we can calculate by this equation. The speed of the rotation P, speed of a rotating P, depends on the frequency. Yes, number of the poles per phase. Yes. So this is the frequency of the source and number of poles on the stator. Number of poles per phase on the stator. So this is for the calculation of the motor synchronous speed. Program, we have to calculate the synchronous speed of the three-phase induction motor having the 20 poles. So it is connected to the 50 hertz source. So we have to use the formula here. And that's equal to 120 F divided by P. So we substitute here 120, frequency is 50, and number of poles is 20 poles. So this we call that there is a 300 RPM. So this is the speed of the machine is 300 RPM. So this is the physical pole. So that what we say pole form by the winding. So there are two kinds of pole. One pole is a physical pole, so this is a mechanical solid revolve the winding. And this one is a pole are formed by the winding. Yes. So this machine means that this one. Pole are formed by the winding. Winding connection from the pole. Yes. Machine operated. Normally we need to supply the electrical supply to the stator. So motor stator is a three-phase winding. So we can draw the stator like this. While the motor stator with the three-phase winding. So this is called a stator winding. So this is a motor stator. Three-phase winding. So motor stator three-phase winding we connect it to the supply. So this is three-phase supply. So this is the flux out passing through. The passing through the two flux are passing through the stator rotor cover bar. So this is called a rotor bar. So when the stator magnetic flux are passing through, the rotor bars are they are the electric flux are passing through the rotor cover bar. So the current induced in the rotor. So this is the current induced current in rotor. So this is induced current in rotor bar. So this current also create a rotational magnetic force. The rotational magnetic force are produced around this rotor bar. So this is the rotation of the rotor magnetic flux. So this is the rotor magnetic field. So this stator field and rotor field are made of interaction and the motors will rotate. So interaction between the stator field and rotor field bring the motor to speed up. So the interaction between stator and rotor field. And bring the motor to speed up. So this is the operation scala, starting scala of the three-phase coagulation motor. The construction of the three-phase machines are winding may be either on the stator or on the rotor, and the windings are the 120 degrees electrical degree apart. The coil may be connected in star or delta. So there are two kinds of the machine. The machine is an induction machine, only got as a stator winding. The other machine will be the one rotor machine. So this is for the induction machine. Induction motor. Induction motor means the construction of induction motor. This is a stator here. Okay, this stator called a slot. So this is a stator winding slot. So on the slot we roll the winding into the slot. So stator winding slot, we roll the winding into the slot. So this is a slot. So this began as a stator winding. So stator winding, and so two windings are taken out as a terminal. So this is the terminal box. So two windings connected to the terminal box. So this is for a stator winding. And this is a rotor, it will be like this. So this is a copper bar. So this is rotor, this bar. So this becomes this kind of machine we call the induction motor. So stator only got the winding and rotor are the copper bar. Another kind of machine will be the one rotor motor. One rotor motor. So one rotor motor means for the stator and rotor, for the winding. So this is for the stator here. This is stator winding, if we roll like this. So this is stator. So stator windings are rolled on the floor. So this is all the stator winding. So this is stator winding. And also for the rotor winding here. So rotor winding, this is rotor. So this rotor here, so this rotor is connected like this. So they are slivering. So this is the one rotor motor. So this is for the rotor winding. So this is also we put the winding inside like this. So this is for the one rotor. So this is on the rotor. We got the slot. This is for the one rotor motor. So rotor one is sliving, and this one is connected to the supply. So there will be two winding. So this one is connected. This one we got to do the rheostat. By adjusting the rheostat system, you can change the speed. So this is for the rotor feeder system. So this one is theta winding connected to the terminal block. And connected to three-phase supply. This is for the construction of the one rotor motor. Induction motor and the one rotor motor construction. So then we need the winding can be the full theta winding and rotor winding. For three-phase machines, induction machine only got the theta winding. Rotor is this because it's a square gauge rotor. That kind of rotor is called a square gauge rotor. And that's why rotor we call the one rotor. Square gauge rotor and the one rotor. So there will be two kind of motor. The square gauge induction motor and one rotor motor. So this is we call a square gauge induction motor. Square gauge induction motor and one rotor motor. The two kinds of motors are constructed. The next topic is a three-phase motor winding design. So now we want to wound the three-phase winding. So normally what we do is we wound the winding here on the former and put into the slot. And then we put into the winding another slot, and we join together. Like this is we design the motor. So then now I told you, I explained how to design the motor winding. So there are motor will be the three-phase motor, 36 slot, 4 So you want the 100 RPM, that's what you want. So how will you design the motor winding? So this is now I show you how to design the motor winding. So for the motor, firstly you have to talk about the quiet band. Quiet band means this winding here, we start from this winding to the end. So this is the way to calculate. This slot, you start from the slot 1 and end at the slot 13. So there will be quiet band will be the square slot. So this is the start from the 1 and so end at the 10. So this means that quiet band will be the 9. So quiet band 9. Start from the slot 1 and at the slot 10. So this is for the two sides. This side is the start from the 1 and this is the final side and at the 10. So there will be the quiet band will be the 9. Quiet band is 9. So this is for the quiet band. So we can calculate the quiet band. So 1 to 9. So 1 to 10 is for the quiet band is 9. So normally we calculate the quiet band by equation. Quiet band is equal to number of slots divided by number of poles. So number of slots is S, number of poles is P. And by this way you can calculate the quiet band. The first step you have to create you have to calculate the a quiet span. The quiet span formula is a number of slots divided by number of poles. This is for the quiet span. So we calculate the quiet span. The quiet span is equal to the number of slots divided by number of poles. Okay, number of slots will be 36 slots. Number of poles will be 4. There will be 9. So this is quiet span will be the 9. And another one is this quiet span we calculate the 9. Now how many are quiet per phase? So we have to calculate. So this means that you also need to calculate it. So quiet span 9. Okay, so this is quiet span 9. Now we want to allocate how to warm this winding. So this is that we start from the slot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Quiet span 9 means slot start from the 1 to 10. So that will be the quiet span 9. To call the quiet span 9, your slot start from the 1 and end at the 10. So then this is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are the slot number. Okay, so on the slot number, I will warm the winding. So this is for the 1 bolt. So that we start from here. We start from this place. This is for the start. Start at the slot 1. So 1 winding, this is for the slot. This is the slot. So the slot. So start from 1, end at the 10. And also coming here. 2 to 9. And coming back. 3 to 8. 4 to 7. I get the enemy to draw. This is start. So we start from the 1. So start from the slot number 1. So we start from the slot number 1. 1 to 10. And then 2 to 9. And then 3 to 8. And 4 to 7. And 5 to 6. So this is end at the 6. So this is for the 1 bolt. So we made the 1 bolt by this way. So how does the motor wind go? The slots are going. So that will be as 1 to 10. And 2 to 9. 3 to 8. 4 to 7. And 5 to 6. So this winding method we call it concentric winding. Concentric winding. Concentric winding means that all the circuits are the same center. So this is concentric winding. You can warm the winding by this way, or you can alternatively warm it another way. So then now I go show you the another way how to warm it. Means that all are winding at the same center. Okay, another winding also you can do it. Now this is for slot 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is another winding. So another winding method we use it different ways. So firstly we start from the 1 to 6. 1 to 6. and go to the 2 to 7, 3 to 8, 4 to 9, and then finally 5 to 10. So that's winding method. So that one is how to do it. It's for the 1 to 6, 2 to 7, 3 to 8, 4 to 9, and then 5 to 10. This one we call the left winding. So there will be the two winding. Either you get wound as a concentric winding or the left winding. But the difference in the advantage of the concentric winding is, if you wound the winding in the left winding, all winding must have the same number of time. This is the one time. So this is the number of time we did it. For example, the whole winding called this how many contacts are? About 10 contacts. This one also must have the same contacts. This one also the 10 contacts. All the winding must have the 10 contacts. Winding means the whole winding too. You have to 10 contacts. Not only one wire. There will be the bigger wire. There are many wire. So to produce the appropriate magnetic flux. So this is the 10 contacts. So every winding must have the same number of contacts. Otherwise, first winding is 10 contacts, second winding is 20 contacts, third winding is 15 contacts. So if after you work, your motor will not run properly. This is the fluctuation like this. But concentric winding is different. For example, outer winding you can put 10 contacts, inner winding 20 contacts, this one 30 contacts like this. So by this you can adjust the winding. Number of winding you can adjust. So this is the best thing. So most of the industrial motor windings we utilize the concentric winding. But the thing is that when you make the winding, you have to make the format. On the format, you do wind the winding. So that to make the concentric winding, you need a different format. That winding only one format. So normally, what you do is that you have to cut the timber plow, and this timber length and the winding length are measured and the wound like this. So that the timber cutting the timber length and dimension, depending on you have to measure the motor floor. Motor floor is got distance and motor length, weight, everything you measure, and you have to cut the timber accordingly. On the timber, you have to put the winding format. So the winding not to be too tight or too loose. If too loose, the windings are coming out to the cover, and the motor shaft can cut the winding. Too tight, you cannot properly put the winding. So this is also the important. Where the winding is the motor winding, this is a very skillful choice required. So this is for we make the either concentric final left winding. So because of this one, according to this program, we calculate the point span, let's draw 1 to 10. And I allocate the winding like this. So this is for the only one pole. Only one pole we put the pin, but this program is a 4-pole machine. 4-pole machine means that there will be the 4 glue of the winding. 4 glue of the winding is required for every phase. So now I give you the how to allocate the winding in the every phase. The 180 degree.
So the coil span is equal to 180%?
Yes, coil span is also 180 degree. Yes, that's nice. So one pole is 180 degrees. So this is the one coil span is 180 degrees. One coil span 180 degrees. Okay, so this is for the sub. Yes, your thing is 10 minutes and
yeah, that's a good goal.
ACMachine got two portions, synchronous machine and the induction machine. So the synchronous machine is the G43 and induction machine is the G45.